Okay, now let's go back to the idea of the F statistic. Now that we've broken it down a little bit in terms of what kinds of different variances there are, hopefully the F statistic makes a little more sense. The idea is that you want to take the ratio of the between group or sample variance over the within group variance. And the reason we want this particular ratio is that we're actually very, very interested in the between group difference. That's what our hypothesis test is all about, whether the groups are different or the same, right? The within group variation, we cannot account for. It's variation that just is inherent in the system, right? And so we need to compare the between group variation, which we care about, with the within group variation, which we cannot explain. We don't have any explanation for it, at least not in this hypothesis test, right? You'll have to do other tests to figure out that stuff. Okay, so now that we're here, what we need to do is replace these conceptual ideas with some of the things that we've been learning about. In particular, the variance between and variance within, right? And so variance, we're going to use S squared, right? But S squared between over S squared within, right? So variance between over variance within. But now we know a little bit, like we've refreshed, oh, what is variance about? How can we break it down in terms of sum of squares? Well, that's what we're going to do. We're going to sort of double click on this guy, and here's what we see inside. We see the sum of squares between divided by the degrees of freedom between. All over the sum of squares within divided by the degrees of freedom within. Right? And this is how we're going to actually calculate our F statistic. Now, we'll write out the formulas for each of these, but it's sort of good to know like where the F statistic sort of comes from. It's conceptual roots. You always want to be able to go back there, because ultimately, when we have a large F, you want to be able to say, this means there's a larger between group variation than within group relative to within group variation. A larger difference in the thing that we're interested in over the variance that we have no explanation for. Okay, so now let's figure out how to break down this idea. And remember, this idea really is the breakdown of the variance between. Right? So we're breaking down the broken down thing. So conceptually, what is this? Well, conceptually, this is the difference of sample means from the grand mean, right? So imagine our little groups, right? And there's some grand mean that all of these guys contributed to, right? But these all have a little, these all have a little sample mean of their own, right? And what we want to do is know the difference between these, right, squared, and add them up, right? That's the idea behind this, right? So first of all, how many means do we have? How many data sets do we have? How many data points do we have? Well, we have a data point for every sample that we have, right? So how many means do we have? Well, how many samples do you have? We actually have a term for that. The letter that we reserve for how many samples is K. Number of samples, right? And so then you could think about, okay, if that's the number of samples, then what might be the degrees of freedom here? Well, that's just going to be K minus 1. Here's why. In order to get the grand mean, we could do a weighted average of these means, right? And since there are 3 of them, if we knew what 2 of them were in advance, the third one would not be free to vary. We'd lock down what that third one is, right? So the degrees of freedom is K minus 1. Okay, so what is the actual sum of squares between? And note, you need to take into consideration how many actual data points are in each group. For instance, group 1 might have a lot of data points. Group 2 might only have a few data points. Which mean should matter more, right? Well, that's going to be taken into account. So first things first, how do we tell it, get the difference between this mean and this mean? Well, that's going to be this, x bar minus x double bar, right? So get the difference between the mean and the grand mean. Now, we have several means here, right? So I'm going to put an I for index. And in my sum of squares, my I is going to go from 1 up through k. So for each group that I have, I want you to get this distance and square it. Not only that, I'm not going to stop there, but I also want you to make it count a lot if it has a lot of data points. So if this guy has a lot of data points, he should get more votes. His difference from the grand mean should count more than this guy's difference, right? And so that's what we get by multiplying by n. If n is very large, this distance is going to count a lot. If n is very small, this distance is not going to count as much. And this is the sum of squares between. So that's the idea. Okay, so now we actually know this and this. So we could actually create this guy by putting these two together, right? Now let's talk, this should actually say sum of squares within. Sorry about that, within. Right. Now let's talk about sum of squares within, now that we know sum of squares between pretty well. Well, first thing we need to know is that this idea, sum of squares within divided by degrees of freedom within, is actually going to give us the variance within. Ta-da! Let's talk about what this means conceptually. Conceptually, this means the spread of all the data points from their own sample means, right? So this is the picture I want you to think of. So everybody has their own little sample mean, right? X bars, own little sample means. And here are my little data points. And I want to get the distance of each set away from their own set's mean, right? This is going to give me the within group variation, right? Makes sense, right? Well, we need to think about, first, how many data points do we have? Well, we have a total of n total, right? Because you need to count all of these data points. So you need to add them all up, right? So we have n total, like the total number of data points. So what is the degrees of freedom? Well, it's not just n total minus 1. How many means did we find? We found 3 means, right? For each time we calculate a mean, we lose a degrees of freedom. So it's really the n total minus the number of means that we calculate. And here it's 3. It's 3 because we had 3 groups. Remember, we have a letter for how many groups you have, and that's k, right? So it's really going to be n total minus k, the number of groups. And that's going to give us the degrees of freedom within. So what is the sum of squares within? Well, the sum of squares within is really just going to be the sum of squares here plus the sum of squares here plus the sum of squares here, right? So for each group, just get the sum of squares. That's a pretty easy idea. So the sum of squares within is just add up all the sum of squares. Now, what does this I mean? The I means the sum of squares for each group, right? And that's I going from 1 through k. So for however many groups you have, get that group sum of squares, add it to the next group sum of squares, add it to the next group sum of squares, right? And these are general formulas that will work for 2 groups, 3 groups, 4 groups, 5 groups, however many groups you want. Okay? All right, so that's sum of squares within. And now that we know this and this, we could calculate this, right? Okay, so now let's put it all together all at once, right? My apologies, because this may look a little bit tiny on your screen, but hopefully you could sort of reconstruct it from what you've seen before, because I'm writing the same formulas, just in a different format, just to show you how they all relate to each other. Okay, so first, conceptually, this is always important, because you can forget the formulas, but don't forget the concept, because from the concept, you could reconstruct the formula. It does take a little bit of mental work, but you can do it. All right, so first things first. The whole idea of the F is the between group variation over the within group variation, right? So that's the whole idea right there. And in order to get that, we're going to get the variation between over the variability within. Oh, actually, I wrote this in the wrong place. I should have written it down in the formula section. So F equals the variability between divided by the variability within. Right? So that's the F, right? Now, for the F, you can't just calculate sum of squares, because really, the F is made up of a bunch of sum of squares. And for F, you actually need 2 degrees of freedom, and that's going to be determined by the between group degrees of freedom and the within group degrees of freedom. So these I'm just going to leave empty. All right, now let's talk about between group variability. The big idea of this is the spread around of sample means around, so I'll put an S there, of X bars around the grand mean, right? That's what we're really looking for, that idea of the spread of all these sample means around the grand mean. However, the within group variability is the spread of data points from own sample mean, right? So for each little group, what's the spread there? What's the spread there? What's the spread there, right? So that's the idea of these two things. Now, in order to break it down into the formula, you first want to take it into what is S squared between, right? It's like you double-clicked on that, that takes you here. If you double-click on this one, that's going to take you here, S squared within, right? So the variance between, the between group variability, this is going to be just the very basic idea of variance. Sum of squares over degrees of freedom, right? Same thing here. It's sum of squares over degrees of freedom. That stuff you already know. But the only difference is we put a little between here. And we put a little within here, right? So that's the only difference. Once you get there, then you could break this down, right? And you could say sum of squares between. And if you forget what the formula is, you could look up here and say, it's the spread of the X bars around the grand mean, right? So X bar minus grand mean. And you know you have a whole bunch of them, right? Squared, sum of squares, right? And you're going to go from 1 up through k, because that's however many sample means you have, right? And you want it to be weighted. You want it to count more. Your distance counts more if you have more data points in your sample. Okay? And then the degrees of freedom is fairly straightforward. It's the number of means minus 1, because when you find out your grand mean, it's going to limit one of those guys, so your degrees of freedom is lessened by 1. All right, so for sum of squares within, let's go back to this idea. It's the spread of all the data points away from their own sample means, and that's just going to be all those sum of squares for each little group, and you already know the formula for that, added together. So I goes from 1 up through k, right? And the degrees of freedom, sorry, I should put between and within. The degrees of freedom is really just this idea that you have all these points, all these data points, n total, minus however many means you found, because that's going to limit the degrees of freedom for those data points, and that's k. Right? One other thing I want to just say right here, it's just this idea that you might see in your textbook, or in a statistics package, this idea called mean squared error. Mean squared error. So this term right here is sometimes going to be called the mean squared error term. So that's a common thing that you might see. This may be called mean squared between MSB, right? Or you might just see mean square between groups or something like that, right? So the between groups part might be written out. But almost always this, this denominator is going to be called mean squared error. The reason I want to mention it here is not only to connect this lesson with whatever's going on in your classes, but also because mean squared error will be an important term for later on when we go on to other kinds of ANOVAs. All right, so now let's get to examples. So first, who uploads more photos? People of unknown ethnicity, Latino, Asian, Black, or white Facebook users. So what's our null hypothesis? And sorry, you might be like, oh, how would we ever know? This data set is found in your downloads. And so the download looks like this. And there's however many uploaded photos. So here's uploaded photos here. So this person has uploaded 892 photos, and their ethnicity is a 0. And 0 is just a stand-in for the term unknown or blank. So they may have left their ethnicity blank. So the Latino sample is 1, the Asian sample is 2, the Black or African American sample is 3, the white or European American sample is 4, right? And so you could look through that data set. I've color-coded it just so that we could easily sort of see where we are.